Welcome back to Mechanical Engineering Design. And what you are seeing on the screen is a Geneva wheel. So a Geneva wheel consists of two parts. That's a part with the pin. It's called a Geneva pin. And the other part, the red part as you can see, is a Geneva wheel. So Geneva wheel or a Geneva mechanism transfers rotating motion into intermittent motion. That means when the part with the pin rotates, it will go into the slot. Okay, when this part rotates, it will go into this slot and give it a motion depending on the number of divisions you have made on Geneva wheel, so that those motions can keep stopping at a given angle. So one application of this Geneva wheel is in analog watches. So you'll see a watch keeps rotating step by step as it counts seconds. So another part is in CNC machine. It's used in indexing tables. So I want us to look at each part and how I drew them, and then we go ahead to simulation. So if you are new to my channel, please subscribe because it means a lot to me. Now let's get started. Now this is assembly, and what we'll begin with is the holder. So I made this holder to hold the wheel and Geneva in place. So the design begins with top plane. Now these are two circles. One circle from the center, distance of 30 mm, and the diameter of 15 mm. So two of them are 15 mm in diameter. And then there is the outer arc of radius 25. The distance between the center of this circle to this one is 60 mm. Now then boss extrude to a distance of 10 mm upwards, as you can see arrow here, 10 mm. Then I proceeded ahead to do fillet along the edge. So this is a fillet of 0.5 mm to give that smooth edge. And that's all for this part. Just save. Now we are done with the first part, and the second part is the Geneva wheel itself. Now, it only took me 3 steps or 3 extrusions. The first part is the major sketch. Now, the outer circle has a diameter of 100 mm, and then you come to slot. This is an arc of 6 mm radius at a distance of 30 mm from outer quadrant, 30 mm. Now, using sketch entities circular pattern, which is here, I made 6 circular patterns. This is the first one, second, third, fourth, fifth, 6 circular patterns. Now, the second sketch is this arc. You see these arcs? They are 6 in number. Distance from origin to the center of this arc is 60 mm. Now, the radius of the arc is 20 mm, or otherwise a diameter of 40 mm. And then give vertical relations from this center to this one, vertical relations. Afterwards, go to sketch circular pattern and give 6 entities. After sketching, go to extrude boss at a height of 8 mm. So at this stage, this is what is ready. We go to the pin, this one. So just select the bottom and sketch from origin, sketch a circle of 25 mm in diameter. Now click on this face and proceed to create this pin. Sketch diameter 15 millimeters. And then extrude a distance of 20 mm. As you can see, distance of 20 mm. And that's how Geneva wheel came up. So we'll proceed to the next part with Geneva pin. Now, the yellow part. So this part came up in 4 steps. So the first, a circle of 80.48 millimeters. with an extrusion height of 8 mm. Proceed to the next part. This pin. So from the bottom, sketch a circle of 15 mm from the origin and just extrude. At a distance of 20 mm. Proceed. This pin, which will now generate the motion. So this sketch from the origin, distance of 30 millimeters, we sketch a circle of 12 mm and then give a vertical relations from this center to this one, vertical relations. Proceed to extrude at a height of 10 mm. Now the last part. This is where we create this sketch from origin, diameter of 40 mm. Now, from the center of this pin, we create an arc of 25.22 millimeters. And then proceed to extrude. Height of 10 millimeters. So once you are done with that, proceed to assembly. This is what we get on assembly. It's a very simple procedure to obtain the assembly. So the first step is concentric relations. Since we have the base flange, which is this one, we give concentric relations between this pin and the hole. Same to Geneva wheel, concentric relations between the pin and this bracket. You see, it's concentric relations. This one is also concentric. Now, we'll have to give coincidence this face this face and this one to be on the same level. As you can see, they are on the same level. And finally, on top surface, it has to be on the same level. You see? Geneva pin has to be on the same level with Geneva itself. Now, and the pins, this pin and this one, have to be on the same level with a bracket. So when we are done with that assembly, we proceed to motion study. And this is the interesting part. Now, on motion study, the first thing we need to select is basic motion. Ensure basic motion is on. Now, another part is to set motion study properties. See this setting. We want to create a smooth animation. So you increase the level of frequency or frames per second that you will see. The higher the number of frames per second, the smoother the transition will be during the motion study. So let me give it a 60. Ensure it's high, and then OK. The next step is to identify the moving part or the motor. So the motor in this case is this part here. This is what will give us the motion or rotation. So you can select on this face, the highlighted in blue color, and you can change arrow. You see this arrow, the red arrow. You can switch depending on direction you want. And the last and a very important step is contact. Let me show you what it means. If I've selected this part to move and let it calculate, you see the wheel will be rotating, but now it will be going through the Geneva. It does not move the Geneva. So we'll have to give it contact. So this is where contact is. This icon here. It simulates contact between the selected components. Now just select contact and select the two of them. The first one and the second one. And click OK. Just as simple as that. Now I want you to see the difference when we calculate. you have to give the software some time to process. You see, it will have to load for quite some time depending on the processor of your laptop. Now see, here is our animation. You see, it's so smooth. Higher frequencies give better results in terms of visibility. So I hope you enjoyed my tutorial. Don't forget to subscribe and also turn on notifications so that you will not miss when I upload another video. Thank you for taking your time, and see you in the next one.